Everyone, my name is Itai Shakuri and I lead the open source team at Aqua Security. Today I wanted to talk to you about Trivy and specifically how it can help you protect against supply chain security attacks using concepts such as SBOM, software bill of material, and the very popular open source project Sigstore. So just as a very quick recap, Trivy is a security scanner. You probably are familiar with Trivy in this form, meaning that you give it a container to scan, it analyzes it, and it shows you the vulnerabilities within it. But actually, Trivy can do a lot more. Trivy can scan not only container images, but also file systems, code repositories, Kubernetes clusters, even cloud accounts. And it can find way more than just known vulnerabilities. It can scan for misconfigurations and infrastructure as code files. It can find secrets in there. It can analyze the software licenses, and Trivy is fully open source on GitHub. You can go after this quick talk and check it out. So back to our agenda. So we have a container image and we wanted to scan it and produce the vulnerabilities report. So obviously the first step that Trivy will have to do, and this is how it worked since forever, is to take the container image and crack it open, analyze it, see what's in it in order to determine what dependencies you have there, what software packages you have there, and then only then it can match them with known vulnerabilities. So this is how Trivy always works, but we now have a name for this particular step of analyzing the software and understanding what it is made of. We call it SBOM. So SBOM is now an industry term. It stands for software bill of materials. In short, it's just the list of things that your software is made of. It's a good thing to know. And it's recently been made more popular thanks to, of course, supply chain trend, and also thanks to the White House issuing an executive order requiring that all vendors will provide an SBOM for their software. So basically, this is the starting point. Trivy takes a container image. It can analyze it. It can produce the SBOM for you in any of the industry formats. SPDX, CycloneDX are two very popular industry formats. And then it can continue to generate the vulnerabilities report. So yeah, Trivy can generate an SBOM. And this is how it looks like. On the command line, you can tell Trivy to scan an image, just like we've seen earlier. This time I will add the format flag, and I will tell it to emit the output as SPDX JSON. This is how it looks like. So this is the SBOM, actually. You can take this SBOM, you can save it, you can archive it, you can do whatever you want with it. This is a valid SBOM. One thing to understand at this point is that SBOM is a fact about your software. It's the list of things it's made of. So unless you changed anything in your software, it shouldn't change the SBOM itself. Unlike the vulnerabilities report, which is temporal information. So it really depends on when you read it, how you should evaluate it. So the thing is that vulnerabilities are keeping being discovered every year, every day, every minute. And this is real data, by the way, that shows how many vulnerabilities are there at any given year. And you can see that there are more and more vulnerabilities being discovered all the time, which means that it's not enough to scan the container image once. So it's considered the best practice to integrate, for example, Trivy in your CI/CD pipeline and scan your software for vulnerabilities, which is good. It's definitely good, but it's not enough, because it might be that the next day after you scanned it, you didn't make any change to your software. You didn't introduce any new code, but there was a new vulnerability that was discovered that affects your existing software. So it's a good practice to also rescan your images or your software all the time. And this is what people do. This is what we do. People scan their container images, for example. They scan them, for example, periodically, every day or on every change. But if you think about it, rescanning the container image involves this step of analyzing the container. For example, extract the container image, you need to merge the layers, you need to analyze the file system, And it's something that that can take some time and resources. You maybe not want to repeat it every time. So for this purpose, we've introduced a very cool feature in Trivy that allows Trivy to actually receive the SBOM as an input. So previously I said that Trivy can generate an SBOM as an output, but it can also receive an SBOM as an input, again in SPDX or CycloneDX, and it means that it can scan an SBOM. Scanning an SBOM in this sense means that you run Trivy like so. Now instead of using the image subcommand of Trivy, I'm using the SBOM subcommand of Trivy, and I'm telling it to scan this time not an image. This is just a JSON file. It's the file that, for example, we generated earlier using Trivy. It's the SBOM, and the result is the vulnerabilities report. All right, so this is good, and you may have already thought about the fact that we've introduced a little bit of risk here, because in the beginning we scanned the container image. That is the actual software artifact that we're going to use. So we scanned the thing that we're going to use. But now that we're scanning an SBOM, we're actually scanning a derivative of the software artifact. We're not scanning the artifact itself, we're scanning a derivative that hopefully is representing the original software accurately. But how can we be sure? So enters Sigstore. Sigstore is a popular open source project from the OpenSSF, and is basically, as it says, a standard for signing, verifying, and protecting software, which really helps us in this case. And the way it helps us is that we can take the SBOM that Trivy generated, and this time, instead of just scanning the JSON file as is, we will first sign it. So we will use a utility that's called cosign. Cosign is one of the tools under the Sigstore project umbrella of tools. So we will use cosign to sign the SBOM. And then we have essentially what's called an SBOM attestation. And Trivy can also scan an SBOM attestation. So this is actually a better practice of how to use SBOMs with Trivy. And it looks something like that. So here I'm using the cosign utility, and I'm executing cosign a test, and I give it the SBOM as an input. I also give it the image that it relates to as an input, and the attestation is actually related to this particular image. And you can see on the bottom that now I am again using the Trivy SBOM subcommand. So I'm not giving it an image to scan, I'm still giving it something else, but this time I'm giving it the signed SBOM attestation, and Trivy can understand this format and scan the SBOM, which is good, which is great. And you also may have thought about the fact that, okay, you starting to scan images, starting to generate SBOMs, and you also sign these SBOMs, start to think about the machinery involved there to continuously generate SBOMs and store them and rescan them, etc. And this is where another piece of the Sigstore open source project can help, because we don't need to think about where to store these things and how to find them. Actually, we can store the signed SBOM attestation in Record. Record is a public transparency log. This is how they refer to it. But think of it, for simplicity, just as a public database containing all the attestations there are about all the artifacts there are. And we can store things there. We can also validate, verify things that are signed there, and we can use them. So in this case, what we can do is sign and push the SBOM to Record, and then Trivy can effectively discover the SBOM at scan time automatically. So it will look something like this. This time, notice that I'm using the image subcommand of Trivy, not the SBOM. So I'm actually telling it to scan just an image. It's a valid image from Docker Hub, but I'm giving Trivy a hint, and I'm telling it, check Record first and see, maybe there's a signed SBOM there that we can use. If there is, and if the SBOM is valid and everything, then you can use it. You don't need to reanalyze. You don't need to pull the image from the registry and extract it and analyze it over and over again. You can just find it there. So this is, I think, when it's starting to become really practical and very cool. So we can close the circle and say that we can generate an SBOM with Trivy, we can scan an SBOM with Trivy, we can scan a signed SBOM with Trivy, and we can discover automatically a signed SBOM for an image with Trivy. One last thing, which is also quite useful, is that we've so far discussed only the SBOM in terms of signing it and working with it, but actually we can look at the vulnerabilities report itself. We can also sign it as an attestation about the image. It's also a fact, a statement that we are claiming about the image. We can sign it, we can associate it with the given image, and we can also store it in record actually as a co-signed vulnerability report. And this is very interesting because it's basically taking the end result of the entire scanning process and making it ready to use. And it opens the door to some interesting use cases. For example, one very common use case that we're getting asked about a lot is how do we integrate image scanning into Kubernetes at admission time? So how do we make a policy, for example, that allows only images that are proven to be scanned and meet our criteria? So for example, no critical vulnerabilities in image that we deploy. How do we do that? Obviously, we cannot scan the image at admission time. Like someone, kubectl creates a pod, we cannot stop the world, scan the image, and then make a decision. It's not feasible. It will also time out. It's not practical to do it in the Kubernetes API. But what we can do is something like this. So here we see the same kind of flow where we scan the image, we analyze it, we created a vulnerabilities report, we sign the vulnerabilities report, store the report attestation in record using cosign. That's all well. And now Kubernetes at admission time, when Kubernetes looks, for example, at a new deployment, it can make a quick lookup to record, and to get the vulnerabilities report, it can look at the data there. It can make a decision based on when it was scanned or what was found there. It can make a decision for whether we allow or deny this submission. So this opens the door really for this kind of use cases, and we made a nice video tutorial together with Kyverno, which is a popular open source NCNCF policy controller for Kubernetes. We made a video that walks through this entire process of setting up Trivy and Sigstore and Kyverno to achieve this scenario. Highly recommended video, link here below. And that's about it. So we talked about the journey that Trivy has made recently, from generating an SBOM to scanning the SBOM, and then to working with signed SBOM and automatically discovering the signed SBOM, and finally to supporting vulnerability attestations. Last week at KubeCon, we announced that Trivy can also scan unpackaged binary files, and this is powered by the same principles of SBOM discovery in Sigstore. So traditionally, Trivy, as any other scanner, would look at the package manager metadata. So for example, if you used apt-get to install something, then it would be registered and Piki would read that registry. But if you just copy something, copy a binary, for example, in a Docker file, a copy command, then it's not tracked anywhere. So we couldn't do anything with it, but now we can. Now we can see that there's a binary there. We can look up this binary by hash in record, and if it has an SBOM there, we would scan it for vulnerabilities. So that's a really cool and innovative principle for how this SBOM and record movement is improving things. This is not the end. We also have other ideas and what to do with Sigstore and SBOM. You can expect more to come. If you have any ideas, please share them with us, either on GitHub or in Slack. You can find us at slack.aquasec.com or reach out to me on Twitter. Thank you very much. I hope you enjoyed it, and see you next time.